Okay guys, so I just want to go through the components, exploded view, sort of like this. Now this video is obviously made before the previous video I'm going to make, or you probably already saw of it running. So some things might not jive, but I'm going to do my best to explain what's what here. So basically you've got your 1 inch drive line coming in. So this pump's 1 inch. You can go bigger. You can go a little bit smaller down to 3/4. I don't know if I'd recommend going smaller than that. Anyway, so to make your life easier, we're going to start with a 1 inch union here, just so you don't have to spin this whole sort of apparatus around a pipe to install it, or if you ever have to do maintenance. So 1 inch union, we've got a 1 inch by 2 inch pipe nipple there. We've got a 1 inch T, another nipple, 1 inch elbow, 1 inch nipple again. And then I'm using the spring type check valves. This is a 1 inch spring type check valve. This one here is modified from when you purchase it. So I'll do a video just after I'm done explaining this here of how to modify these. Very simple. But basically, as the water comes in here and has to be stopped once the water overcomes the valve. So with the flapper type valve, just the weight of gravity holds the flapper down until the water overcomes it and it slams shut. With this type of valve, you have to modify it so that when the water tries to go through here, as you can see, there's the valve itself, and that's in the open position. The water's flowing that way. As the water comes in, it's going to overcome it and then slam shut. However, it doesn't come from the factory like this. You have to take this little screw off, which again, I'll show you. And I have the spring in here holding the valve open. You can either leave that spring in, hold the valve open, or you can take the spring out completely and just allow gravity to leave that valve open. It sort of depends on your flow rates, and you have to experiment. So I would try it without the spring first, then try it with the spring, or like a little bit of a lighter spring. You're just trying to get the effect where the water comes in and slams that shut with the flow rate that you have. So I left the spring in. Then we'll move to the pressure side here. So another nipple, and then we have a normal spring type check valve. Again, you can use a flapper type check valve here. This one is unmodified. So you can see from the arrow there, where there's the arrow, the water flows this way and will not come back that way. So this one is non-modified. Another nipple, 1 by 1 by 3/4 T, 3/4 nipple, ball valve. This is optional. This is just connect to a garden hose, goes 3/4 to garden hose. You can also do like a 3/4 barb to a longer, poly pipe, something like that. Whatever's easiest for you. This is the delivery line. You can do pretty much whatever you want. And then we have our air chamber. Again, you can mix and match this stuff. These are just the parts I had, and this is how I'm making the air chamber. You can do it out of ABS. You can do it out of steel. You can do it out of a fire extinguisher tank. You can do it out of anything you want, propane tank. So you've got a nipple here. I've got a sort of a bell or a reducer, 1.5 to 1. And I use this PVC 1.5 to 1.5 threaded to glue. This is 1.5 to glue PVC, 3-inch PVC cap. And then I have a 24-inch long PVC air chamber, which is sized correctly for this size of pump. You can go bigger depending on your driveline size. And there's documentation on the internet if you need to know specifics. But generally, a 2-foot long pipe works very well. Because I made this video before I'm making the other video, I don't know exactly how I'm doing the pressure system. So there's one of two ways. You can put a bicycle inner tube or some type of bladder inside this tube. And what that does is, so basically over time, this thing is about half filled with water as the system's working. And that's the ideal place you want the water. Just like a well tank in your house, you need to have air pushing water. But over time, the air dissolves into the water, and eventually the water will creep up to a point where there's just water in this tube, and the valve will start slamming shut too hard. It can end up destroying the pump or the valves. So you always want to keep air in there. So one way is putting the bicycle inner tube, which I may do, or one way I actually like better, and that's just because there's less moving parts. So obviously the inner tube can wear out over time, a long time, but still. We are going to maybe do a snifter valve. So like I said, whatever the video was before this is how I did it. But you drill a very small, so 1/16 or smaller hole right in here, or you can do it just below the actual valve part of the check valve. And what that does is every cycle on the low pressure part of the cycle, it just for a millisecond just pulls in a bubble of air. And that bubble of air waits right underneath the valve until the next pressure cycle comes in. The water rushes in, that one bubble of air also rushes in. And it keeps a bubble of air every time in this chamber so that the air stays at the same level in this chamber all the time. And you don't have to worry about it getting waterlogged. So I like that system a little bit better. I'll probably end up going with that, and likely I did. The only thing I'm worried about is in winter, if this thing is running in the winter, that little tiny hole spraying the water out very cold days could potentially freeze over, so it wouldn't work in the winter. But not too worried about that. So those are the components. I'll quickly just show you how to take apart this type of valve and get that ready for assembly, and then we'll do a quick video of it being put together. Okay, so this is the factory valve. This is what it looks like when you'll get it. Basically, it's spring-loaded this way. So water can go this way because it pushes the valve out of the way. So that's open, closed, and it's spring-loaded that way. So we need to reverse that so it stays open via the spring or just by gravity. So I've taken this one apart to show you. Basically, the valve is in there like that. The end of this rod goes through that hole, and then it has this washer on it, then the spring, and then the lock nut on the end. So I've taken it apart. We're going to reverse that. So basically, same thing. So here's our valve, except we're going to put the spring on the valve first. I just put the big end down, small end up, and then we're going to feed it back. We're going to put the valve back where it was, but now it has the spring on it. That's a little easier said than done. But basically, I'm just trying to feed it through that bushing hole there. Okay, I think we got it there. Okay, so there it comes through. You can see that. So now my finger's holding it closed when I push on it, and the spring's pushing me back. And then you can throw this little washer back on if you want. It's not really necessary. And again, you can go no spring and just use gravity to hold it open. And then we'll put our lock nut on. And then a 10mm socket on there. And on the back of the valve. Tighten that down. So there, we've modified that valve so that, as you can see, the valve is open. You can see light there. And then when the water starts flowing this direction, it'll slam the valve shut. Open, shut, just like that. So on your pump, the valve will go in this direction with that facing up, just like that. Water's going in there. So I've got my ram pump here installed. So I've got it on 32 feet of 1-inch iron pipe, and the water level of the dam up there is about 3 feet higher than the actual pump, or the union there. So modifications I made since building, I took all the bushing and washer out of this one because I left it in when we took it apart. So I took that out just because it was binding up the valve. And then in this one here, it had the spring in still. I didn't modify it. I just took the spring, bushing, and washer out. So it's just the valve going up and down. And then, as I was saying in the build video, I didn't know if I was gonna do this, but I did. I drilled a 1/16 hole, 1/16 of an inch. And then I put in a piece of aircraft cable here, double wide, just to slow the flow a bit. If you had a smaller than a 1/16 drill bit, that would be ideal. And so on the low pressure stroke, it lets a bubble of air up into the air chamber so it doesn't get waterlogged. And so I've got this on a 1/2-inch poly pipe, 200 feet long, and we'll go to the end and see how much flow we have. Okay, so the water's flowing, and I've got this 1-gallon container, and we'll see how long it takes to fill it. I'm gonna have to shut the video off just because I got to use the timer on my phone. Okay, so that took 3 minutes 30 seconds exactly to fill. I think that's a little over a gallon, and you'll have to take my word for it. But that's about 400 gallons a day over a 24-hour period. So yeah, pretty happy with that for the size of the ram pump. It's a 1-inch ram pump with 3 feet of height and a 1-inch feed line, 30 feet long.